Hello everyone. Today I was thinking that we should take a look at building a module for a software called Barista. Barista is an alternative to the i3 status written in Go, and I've been using it for a couple of days, and it seems quite nice. The module I want to write is something where we can show in the status bar that the mic is actually receiving any kind of audio. An issue I've had with this microphone is that for some reason sometimes it just doesn't pick up audio when the computer is rebooted, and I was thinking that if I can have a visual in the status bar, perhaps make it red when it's not receiving anything, or perhaps make it yellow if it's having any issues, or perhaps muted, then I wouldn't record any videos like this without actually being sure that the audio works as expected. Because that has happened for me, where I've been recording for perhaps 30-60 minutes, and when I'm done there's no audio, and it's quite annoying. So yeah, that's the idea today, to write a module for Barista, and there's a contrib repository that I've just forked, and I was thinking that I should make a pull request to that contrib modules here. So Martin OH Man has this repository. I was thinking that we should do a pull request here. So I've prepared a few things that I'll show you now. The first thing is I've prepared a simple, small main module. I call it Simon's status bar, and we're using the Barista software here, or the library. So in the main function we just do run, and if run returns an error, we print out application returned an error. Then in run we create a signal notify context, and if we receive interrupt or kill, the context will be cancelled. After that we load a couple of colors for Barista. So we have good, I think that's green, and bad red, and degraded yellow. After that we just run barista add, and we add the specific modules. In this case I have, as you can see in the bottom here, my mic and the percentage it's on right now. Then we have the sysinfo for the CPU, and I'm not sure you will be able to see anything else here because my face will be in the way. And then we have memory information, and then we have disk space information, and the current time. Then I just run the execute, and execute simply runs a Go channel with barista run, and if the Go channel returns an error, we return the error. If the context is cancelled, we return nil. And context will be cancelled if we press Ctrl+C as an example. And my thought was that we should do something like this: barista add, and then let's call it mic amp.new. This doesn't exist right now. micamp.new, and perhaps my microphone name blue microphones. It could be worth noting that the mic I have is a Yeti Blue, and I think it's called like this. We can take and I'm using Pulse Audio right now. Pulse Audio works just fine with Pipewire as well. I've also prepared the fork. So in the Go module, I've just pointed the contrib modules to a local folder. And let's take a look. So it should be modules, and we should create the new module in there. So it should be something like this. Modules, micamp. Let's start with that at least. And new micamp, let's call it module.go. I'm not sure what they call them. IP keyboard. All right, let's call it micamp. Micamp.go. Package micamp. New, and let's see what new should return. New controller. New. This one seems to be taking a provider and layouts. That's not really interesting right now. But it should return a module. And the module requires a stream. Yeah, that's correct. So the micamp we should add. Let's see here. Type module struct. New should return a module. And module should have a stream. Something like that. And go more tidy. Right. And perhaps we should take the new, we should add it like this. New mic name, mic source name string. All right, something like that. Not sure why this isn't updated. Have, want. Perhaps I should close this and open it again, see if that works better. Let's see. Yeah, mic source name. All right. Well, that's awesome. Right now, this would most likely do nothing, so we need to figure out what we actually want to do. So let's do that. If I remember correctly, new should return a module like this, and then the module needs to have a stream, and the streams should set up everything. So and it should then be in a for loop, kind of like this. And just to make sure that I'm not sure, it doesn't seem like the barista library or software doesn't work with contexts that much, but I do usually want to work with a context to be able to cancel. So we'll do something like this, and perhaps we should take a context here. and let's pass that context in here as well. And pass the context like that. It's weird that this doesn't seem to be updating right away, but let's hope this was the last time we have to restart. Alright, let's see here. Yeah. Now we have the context, and in the for loop we should be able to do a select, and let's see here, select case ctx.done should just return, and that's not ctx, that's module. And then we will have another case that's a timer, and the timer should most likely be, let's see here, if they have any schedulers. Scheduler, yeah, they do. So we have a new scheduler here. That's something we want to use as well in our code. So a scheduler, and the scheduler should be scheduler and we should do it every, let's say, 1 second. So this will make sure that case m.scheduler.c, and in this case we should just like m.process, we should do something. And let's just func process, and this should do something. Alright, so we should be able to just see what happens here. So let's print something. Printf os.standard error processing. We should see that each second or something like that, if this works. Make run processing. Alright, and we should add a new line there as well, and perhaps we should just look at, alright, processing, that's awesome. So we can now see that we're at least doing something. That's awesome. Now we need to start figuring out what we actually should be doing. So let's see here. From what I've seen others do when it comes to these modules, they have something called a provider. So the module will have a provider, and that provider in our case should most likely be Pulse Audio, where we get the where we look at the stream of audio going through Pulse Audio. So let's see here, Golang Pulse record. I think this one should be the one we want. And they have an example of how to record, so that's awesome. So let's create a provider, and the provider, perhaps we should make the provider an interface as well. Like provider, yeah, something like that. Type provider interface And let's see, we should most likely have something that close, so we can close all the streams, and we should get the, I think it's called amplitude, and that should give us the current average. So float 64, something like that. Yeah, sure. So we want to create a provider that has these things. So let's do that. Provider, package mic amp, and let's create the new provider type. Pulse. Let's call it pulse provider. Pulse provider. Perhaps someone else wants to. Pulse provider struct, something like that. Func new pulse provider. We should most likely have the mic name, mic source name string. It should return a pulse provider, something like that. My best guess is that we should have an error connected to that as well. So nil trf not implemented yet. Right, and either, so if the mic is disconnected and reconnected, perhaps, I'm not sure exactly what happens with pulse audio, but my best guess is we should just stop everything and restart it. So that means that we should most likely not create the provider in here, but we should create the provider perhaps here. So we should do something like m.mic, let's say provider, let's say is provider. Oh, let's do it during the processing. So let's do it here. If m.s provider ready, and if it's not ready, we should just return. Yeah, let's try that. And let's just print something like processing. Yeah. Provider not ready. And provider ready. And let's create that as well. So we should call it is provider ready. And that should return a bool. And if m dot, perhaps we should is provider ready. Yeah, let's start here. So if it's not ready, what should we do? We should first check if m.mic provider equals, not equals, nil. Let's start it. Return true. Return false. And if, in this case, perhaps we should have something like force as well. So if it's not nil and it's not force, then we should do something like provider error, new pulse provider, and the mic source, of course. Then we need to store the mic source somewhere. So let's do that. Mic source name, it's a string. Is provider ready? We shouldn't force the first one. New pulse provider, m dot if error not equal nil, false. Otherwise, provider m dot mic provider equals provider. And we need to return true. Yeah. And then we need to add provider mic pulse provider. We should have close, and we should have func p pulse provider amplitude should have float 64. And let's just do something like that. Perhaps we should do math.none, not a number. And if it's ready, we should do fmt. Now we know we have it, and processing amp equals, and we should do something like amp equals m dot mic provider dot amplitude, and then we just print it like that. Let's give that a go. We should see provider not ready all the time. All right, fine. Perhaps we should just return nil and pulse provider like that. All right, we're at least seeing something now. So let's get started. We want to create this, and we want to do it like pulse.new client. Oh, that's the wrong place. Go tidy. And client application icon name. Oh well, let's pass the name Simon's status bar. What else can we do? Pulse dot service string. Well, it should be fine. And the new client returns a pulse client. So let's store pulse client like that. And let's see here. Client pulse client error. If error not equals nil, return nil error. Yep. And we should do pulse client dot new record. Let's see it. Client new record, and we'll do something like this. And we need to close the client as well. That's why we have close here. p.pulseClient.close. close. Yeah. And then we want to have a float, and it should create file. So a file has right. All right. We have to do something that has that. So let's call that a sampler. Sampler. I think let's call it a Vav sampler, perhaps. Sampler. And create an interface for that. Type sampler interface. Yeah, let's start with that. And if we do it like that, Vav sampler dot write. Yeah. And we should most likely sampler. So now we store that in here as well. And new record returns a stream and an error. Pulls stream error. If r not equal nil, turn nil up. And we should store that stream as well. Pulls stream. And pull stream dot start. Yeah, should start that, and we need to close p dot pull stream dot stop, p dot pull stream dot close. So we need to stop the stream when we close it, and we need to write. So that means we now have a stream, and the sampler should most likely well, we don't actually need amplitude in here, because we should have that in the sampler. So we have the provider, and that means we can do something like this. Sampler. And if we store the mic provider, mic sampler, yeah, we can amp mic sampler amplitude. Yeah, that's all right. And now we should do m.mic sampler. Yeah, that's good. And that means we need to create the sampler here. Vav sampler, new Vav sampler. All right. So now we need to find out how that works. We should most likely do something like defer module close func module close, and if m.micProvider equals nil, do nothing. Otherwise m.micProvider.close. Yeah, So now we defer it there. Yeah. So now when we exit from here, we will make sure that we close all the streams. Now we need to create something that's called a sampler. Blur.go package mic amp new web sampler, and that should return web sampler, something like that. Type web sampler struct right, and the WAV sampler needs to have that right thingy. So need to have, let's see here, pulse audio, we need to have amplitude and right. All right, func and math.none. So now we have the initial sampler at least. We have a sampler mic. Well, let's call that a WAV sampler here. Yeah, that's fine. And yeah, let's see what happens if we processing. All right, we're back to where we were before. That's awesome. So what do we do? What do we need to do now? Well, the pulse provider will now be writing to the sampler, and yeah, and how should the sampler work? Well, we should most likely have a mutex on that, on sync.mutex, and when we receive the different amplitudes, I think it's called amplitudes, but let's see here. Mutex sampler.mutex.lock sampler.mutex.unlock. Well, this should be the length of P. And from here we want to take, I think we will receive lots of different numbers here. Let's just print those numbers out, and let's see what that means. Let's see here. For I a range P, f and t, f print f. Let's print that to os.stgr and do something like f 0.3f and a. Let's skip the index. So let's do something like amplitudes. Something like that, and when we're done we just do a new line. We'll see what happens. Hello. Oh, well, that's lots of numbers. Well, that's all right. So we should most likely just take these numbers and perhaps do the average on them. Let's start with that just to see what happens. So function, let's call that, and average, let's take float 32 and return a float 64. And let's see here. We'll need to do something like, what do we need to do? How do we want to use it? We want to use it like this. Average is calculate average. Yeah, that's a better name. Calculate average. We'll pass p, and then we'll do average amplitude will be f 1.3 f, and new line average amplitude, something like that. So what do we need to do here? We need to summarize all the numbers. Do we need to do that? Well, I think, well, let's try that at least, see what we get. So we will have something like sum that starts at 0, and we need to take the sum divided by the count, but we have the count already. All right, so for range p, we have to say, so let's make that float 64, sum plus equals f, float 64f, and then return sum divided with the length, and the length here should be of p, and convert that to float 64. All right, let's see what it says. All right, so we will have both positive and negative numbers, and to be honest, the amplitude is like the tops and bottoms of the waves, so we should most likely do something like math.absolute, and math.absolute takes a float 64, and that should give us some numbers. Yeah, sure. And if we just print it like this and I talk a bit higher, let's see if it works. So hello, 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 hello. Yeah, seems like we're getting higher numbers. And if I understand correctly, if we just scroll up a bit here, we can see that we had like 0.3. So it's a scale from 0 to 1. So we do the calculate average, and now we have the average, and we receive lots of these, so we need to store them somewhere. So we don't want to have a too big buffer. That means that we should do something like ring dot ring, and we should make that a pointer. And R should be a ring dot new. Let's just say 32, because why not? And all right, so now we should start doing something like, we want to calculate the average, and we want to add this average to the ring. What's going on here? s.r.value equals average amplitude. Let's call that, yeah, sure. And if I remember correctly, we need to do like s.r.next. So we start rotating in this ring of 32 different things. But either when we go, now we should either, let's see here, do we want to calculate the average of all the 32 different numbers when we run amplitude, or do we want to do it live each time we write? I'm not sure. Let's start with doing it when we run it. So that means we should do something like, we need to utext dot, we need to lock it, and then of course unlock it. And when we've unlocked it, we need to do something like this. And it seems like, we're using 1.14 here. That's weird. Let's be nasty and upgrade that. Let's just do go mod tidy. Or perhaps we could do it like that and go back to 1.14. Yeah, sure. And yeah, that seems we shouldn't have to update everything just because of that. So if a is nil, return. If a isn't nil, we want to have a buffer of float 64. I want to do something like value okay a dot float 64. If it's okay, we want to append buff equals append buff value, like that. So we typecast a to value, and we get a bool back if the typecast went right, and then we just append it here. And when we're done here, we want to take the average of everything in this. So let's calculate average 32, 64, 64, and then we just remove this. And we update this to 32, and then we return. Let's average amplitude 64, and that's buff. And then we can return this. All right, and now we should be able to do something like, let's see here. We want to printf amplitude something like that. All right, so now we're seeing something at least. Processing. That's awesome. We can remove this one, and we can just move this here. Hello. Yeah, it seems like that is working. And if I try to be really silent, hello. Yeah, I'm fine with that. So now we have a ring with 32 values, and it will just rotate around. And we will calculate the average of the ring when we run amplitude. Yeah, that seems all right. So what else should we do now? Well, this one looks all right. Now comes the interesting part. So this will run each second, and when we cancel the context, we press Ctrl C, we'll jump out of this. If we run close, which we do when we're done here, well, all right. So what happens if the amplitude we get is, I don't want to disconnect and reconnect the mic when recording, because that's just a recipe for disaster. But let's say if it returns 0, let's see here. If, let's see, amp is float 64 0 or math.isNaN amp, then we should do is provider ready and force that and return. So that means we skip this, we go here, and we should most likely, well, if we do since we create the sampler, and we will store the sampler outside of so the provider, if that stops working, the sampler will still have like it won't be updated. So we need to keep track of when the sampler last was updated, and if it's been stale for, let's say, if it's been stale, oh, let's see here. Last update and time dot time. Time dot now. If time dot since, let's say something like that, is as the last update, if that's bigger than, let's say, something like that, return math.none. So if we're not receiving anything here for 10 seconds, we'll start returning none. And that should mean that we go into this and we should be updating it. Perhaps we shouldn't wait for 10 seconds. Let's say we want to wait for 2 seconds. And let's just printf long time since last update, something like that. A long time since last update. Am I writing that the wrong way, perhaps? And if we make that really small, time dot nanosecond, yeah. So if we haven't been receiving anything for, let's write a comment for that. If we haven't received any updates using write for 2 seconds or more, turn none, not a number. Something like that. And let's say last, well, Well, that seems alright. Good. So now we're seeing this, and we should most likely let's see here. We calculate the amplitude. Let's remove this. We force it here, and let's see what's next. I think we need to if we should do m dot close here, and we should set m dot mic provider to nil, and m dot close. If it's nil, we don't do anything. That's all right. So, and we should, in this case, if m dot mic provider not equal nil, m close. Oh, but we can just do m close here. So if we had a provider, we'll close that one so we don't have lots of streams open. Well, that seems all right. And now we want to start. So the first thing is we can't really test this. I have no idea how to test the pulse provider, but the sampler should be a bit easier to test. So let's start with that. Sampler test.go. Package mic amp, test, and we have sampler. Something like this. We have sampler equals new web sampler, and let's just give it something. Let's say we want to produce something. Test generate fake amplitudes, and that should return float 32, a slice of float 32s. And perhaps we should just take c int 4, and let's make that start at 1 and go to c, and then result is a float 32. Result should be append 32i, something like that. Then we just return result, and if we sampler dot write generate, and we should pass the t testing t here, t dot helper. Yeah. And let's make that 8 t8, and let's use require, equal, I have no idea what it should equal though, t expected 1, 2, 3 of sampler dot amplitude float 64. Well, let's see what this generates. Run test. Actual 4. So the average of 1, 2, let's see, 1. What happens if we do it like that? 4, 5. Well, that's fine with me. Let's say 4. And if we write 16, what do we get then? Actual 6. And if we write 32, perhaps we shouldn't do 32, we should do 8 again. 5.3333. Well, that's annoying. Let's do it like this. Well, let's do it like that. And we get 8. Expected 6, actual 8. 16. Oh, well. And then we get 16. Yeah, that seems alright. So it's half, and that's correct. And the interesting will be if we do 64 here, we shouldn't get 16. We should get 32. Yeah. Expected 16 got 32. What happens if we run it like 8, 8? What do we get then? Actual 4. Well, yeah. 16. Actual 6. That seems alright. Let's start with that. So now we have a test for the sampler. I know they have some kind of tests we can write for this as well. But before we do that, I would like to take a look at the outputs. So you should have something like an output function, yeah, like that. And then you have to do something like m, and then you return m. And you can set the output function like this, and in this case we want to start with so we don't have anything called layout here, but we could start with, let's call it amp float 64, and we want to print outputs text. So I would like some kind of bar that I would like it to look something like x n%, so like say 12%, and that would be something like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, or perhaps that would be more like this. So I would like something that looks like 2%, would look like that perhaps, 12, 22, perhaps I want it to be like, yeah, something like that. And I want 92 to be, and 100 to be, I think that's all right. And perhaps Unicode loading bar, Unicode microphone symbol, studio microphone. Let's have it something like, yeah, something like that. That would look sweet. So how do we do that? And if it's 0, float 30, float 64, 0, then it should be yellow. And if there is any error or none, it should be red. So that should mean that if the mic is muted and we actually get 0, we get yellow. And if we get any kind of error, like we're not able to create our perhaps we should just use none as the error. So if we receive none, we do red, and that should be perhaps something like that, red. And yeah, that seems like something I would like. So it's 0%, and that's floats 64, 0, and not just it being rounded down to 0. Well, let's see. So we have this. So let's just say bad and degraded. I think that's yellow or orange or something. Right. So let's try to create this. Let's do that at the bottom, perhaps. Func generate progress bar amp float 64, and it should return a string. We have this. Right. So if amp math.amp, perhaps we should pass it the sync as well, or bar output. Let's see here, output text. Perhaps we can do it there. Let's not create a separate. If amp math point is none amp, then we should just do return outputs dot text, something like that, and color dot I can't remember how that's done. Let's see here, colors scheme, colors point hex. So none should be, and if amp equals float 64 0, then we should make it return, and it should be yellow or orange or whatever that is. Otherwise, switch we need to convert this to a percentage, and let's see, I can't remember. Golang convert float 64 to int. Oh, all right. Let's say percentage is int. We receive the amp here times 100. Yeah, wich on percentage if percentage is, let's see here, and percentage is, oh, I can never remember, is smaller than 10. What's going on here? Why can't we do that? Golang is wich less than. Switch our. Oh. We should just do it like that. All right. And perhaps we should I need to test this, so well, let's just start. We should generate the bars. So let's not do it in here. Let's generate the bars outside. Func generate percentage bar float 64 return a string. Yeah, sure. And now we can test this. Return 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And let's just default to return R. Yeah, sure. And let's create a test for that as well. Otherwise, return fmt as printf, and we want the something like that. Yeah, and we need to do padding here as well. Let's try to figure that out in a few seconds. And we want to have a percentage after that. And well, we should be able to just say padding can be like this, because we want to know that it's between 0 and 10, and it can actually be 0 here without being a float 64 0. It's just that it's too small. And if we do, let's do the 20 case as well, or 10 to less than 20, that we should have the first one. Yeah. And then we want to add a nice little icon like that. Let's just select how many they are, and that's 10 selected, 10 selected, right. And the case when we have percentage equals 100, then we should only have one space. All of these should be filled. 3, 4, 5, 6, 7, 8, 9, 10. Yeah. And then we should do add 22.99 as well. And perhaps we should just let's start with this. Now we can make a small test, mic amp.test. Go. And let's see. Test generate T, testing T, func, like that. And if we now do bar equals, if we pass it generate percentage bar, we pass it 0, we expect require equal we should be able to do something like this, and that means we expect it to look like this. And if we send it to 1, 0.001, we expect it to give us 1. Let's see what the test says. Oh, we have an error somewhere. Sorry for that. Oh, I can't have that, sorry. And otherwise, return generate percentage bar amp, like that. Actual, oh yeah, well, expected. If we send it like that, we should see 0, and then we should have percentage less than. Is that the way you do it? Expected 1, received this. Yeah, and then we give it twelve, yes, something like that. Yeah, and 22. And these 32, 42, 42. No, it's just 22, 32. 42, 52. Let's just add all of these now. 52, 62, 72, 82, 92, 99, and 100. So let's 42, 52, 62, 72, 82, 92, 99, and 100. That's all right. And let's update 52, 62. And test it, and on 22, yeah, because we haven't added them. (20 to 30). (30 to 40). 40 to 50. 50 to 60. And let's (60 to 70). 70 to 80. 80 to 90. 90 to 100. And then we have 100 there. Let's run the tests again, and they went through. That's awesome. Something like that. And if we get here, we do, let's say we print something. And let's add that to the test as well. If we get 2, copy. That seems all right. Okay, so we don't need this anymore. have a stream where we process it. We close it here. Yeah, sure. And the sampler, should we verify that if we play around with we create a new sampler, we add 8 to it, timeout. So web sampler dot last update is time dot now. Add time, let's see, what did we say, 2 seconds, let's say 1 second, time dot second. Didn't do all of these tests still work yet? They do. And we add 3 seconds to it. Perhaps we should say minus 1 second, minus 3 seconds. There we go. And then we should have math.none. Expected none. Actual none. Why is it complaining about this? Perhaps we should say true. Math.is none. Yeah. Now we just verify that it works as expected. All right. So now we need to start passing the values. I can't really remember exactly how you did that, but if let's see here, it should be something like the output func. As output. Output func.set. Let's check out. Custom modules, formatting output. It's an example of funcs. Writing a module. Right. So we want it to be something like mistaken. So let's take that name. And that should be a float 64 now. Amp. And that should be a module dot oh yeah, we should pass, perhaps we should create format. Let's just create the func module output amp float 64. And we should pass the sync. I think that's how you do it. And we should take the sync here as well. Process should pass the sync there. And we should say m.output as math dot not a number. And we should pass amp here. And this means that we get up to this, we will print something like that. Yeah, sure. And now let's go back here. Let's try this. I've created a small install script that just installs this bar into barista status and restarts it. So if it works, we should see it come up here in the bottom. Man, alright, hello. Well, that seems to be working. That's really awesome. Let's talk a little louder, and yeah, that seems to be working as I want it to be. That's really awesome. Well, let's do a small commit and call that the initial work of today. Git add modules mic amp. Commit add initial code for microphone amplitude. This patch creates a small status bar, creates a module for barista that show how loud amplitude the mic currently is. Let's start there. And let's push that. Well, alright. I'm quite satisfied with this change so far. So yeah, I think that is all for today. I will link to the PR when I have created it in the description. Thank you for watching, and have a great day. Bye bye.